Hello everyone. Today I will be going over 6 to 18 even from the worksheet 5.4 practice B you were assigned on Wednesday, right? And it's a good review in general because this is what your next and last test will look like for the year. So feel free to forward through this video if you obviously got these problems, the beginning problems were easy for you, and just go straight to the one you had trouble with. So here we go. The first problem I notice is we have two trinomials in the numerator and denominator. So this is, and their leading coefficients are 1. So this is product and sum. So product is negative 11. Sum is 10 here. What two numbers would do that? So right away I split up x and x and I fill in the numbers. So that would be positive 11 and negative 1, right? Because if you think about it, 11 times negative 1 is negative 11, and 11 plus negative 1 is 10. So there you go. Now the denominator. Product is negative 8, sum is 7. So what two numbers multiply to negative 8 and add to 7? That would be x plus 8, x minus 1. Okay? Now once you have factored, now is the easy part, which is crossing out what is the same in order to simplify right here, these x minus 1s. So your answer is what remains. So in the numerator, x plus 11, and it comes out of the parentheses because there's nothing left to multiply. And that's it. That's your answer. Don't try to cross out the x's or do anything else from there. You are done there. Okay? The next problem. Next problem does not require any factoring. And again, how do you know that? You know that because there's no plus or minus signs. Okay, so everything's kind of just stuck together. So we go right into just multiplying them. But actually, if I multiply here, I'm going to end up with really large numbers. So I want to first actually take this 44 and this 22 and cross divide here. So 44 divided by 22 is just 2 over 1. Okay, so see what I did there? Just to kind of make the numbers a little bit smaller. Okay, now I'm going to multiply the numerator and the denominator together. So 2 times 12, right? This 2 here and this 12, it's going to be 24. And then x to the 7th and x to the 1st, x to the 8th. The y's, we add them, that's 9. Now the denominator, 5 times 1 is just 5. And then again, this is a 1 here. So x, and then the x to the 5th on the other one was x to the 6th. And then the y's will turn into a 5 because again, you're adding. Now, see if you can reduce 24 over 5 cannot be reduced. So it's going to stay like that. Okay, now the x's and the y's, the same base, we subtract the exponents in division. So that would be an x to the 2nd and a y to the 4th. And that's it. You are done there. Okay. All right, moving on, number 10. Number 10, obviously here there is factoring because again, the plus signs and minus signs. So both of in the first fraction, both of them are product and sum. Okay, and again, the product is, in the first one, 3. Sum is 4. What two numbers multiply to 3 and add to 4? That's a no-brainer, right? 3 and 1. Okay, and the denominator, product is 6. Sum is 5. What two numbers work there? That would be 2 and 3. Okay, second fraction. Second fraction numerator is definitely another product and sum. So what two numbers multiply to negative 10 and add to negative 3? That would be negative 5 and positive 2. Now the denominator, be careful. Denominator is not product and sum here because there are only 2 terms. So what could you do instead if they have something in common? they both have an x. So x parentheses x plus 1. Okay, because what I did there was I just divided them each by x. All right, now comes the fun part, slashing out. Yes. I'm gonna use white this time. Okay, so let's see, what's the same? X plus 2, x plus 3, x plus 1. All right, so we see our final answer right there is x minus 5 over x. And again, don't try to cross those x's out. Common mistake there. All right, moving on to number 12. Number 12, right in the first numerator, I see another x in common. So x is going to get divided by each here. And what you're left with is x parentheses x to the second minus 9. But hold on a second. Before you think you're done there, x to the second minus 9 is difference of squares. So this has to further factor. So this is the final factored form is going to look like this. X minus 3, x plus 3. And if you're confused and you don't know what I just did, go back to the factoring video I shared last week. Or was it this week? No, it was this week. I'm sorry. Okay. Now, moving on to the denominator, product and sum, right? So that's going to turn into x plus 3, x plus 3. And again, how did we do that? Because product here was 9 and sum was 6. Okay. Just realized that factoring video was last week. I'm confusing weeks, but anyway, moving on. The second numerator. Second numerator is another greatest common factor. So here they both share an x to the second in common. So here we're going to divide x to the second, and we're left with x plus 3. Now the denominator can't factor, so it's just going to stay like that. All right, now the fun part, slashing. All right, let's see here, a lot of things. I see a lot of x's, x plus 3s and x minus 3s, but we can only cross out 2 at a time. So let's start with this x minus 3. I'm going to slash that out. And I'm going to slash this x plus 3 out. And then I'm going to slash these x plus 3s out. Okay, so as I see, my denominator is clearly empty. It's just a 1 now. So what's left is just this x and this x to the second. So my final answer is just x cubed. All right, moving on. Number 14. 14 is showing division, right? So right away I'm going to flip the problem, the second fraction only, as discussed in my previous video. Okay, now no factoring, right? And again, with no plus or minus signs, that's how you know there's no factoring. So go right into, well, we can combine the fractions, but I see really large numbers, so I really don't think that's a good idea right now. I say, let's try to reduce these numbers. So let's start with the 16 and the 24. Think of a number that they can both be divided by to make these numbers smaller. I want to say 8. 8 is a number that's definitely going to make these smaller, right? So let me use green. So 16, if I divide that by 8, that's 2. And if I divide 24 by 8, that's 3. Okay? All right, now let's look the other way. 81 and 54, right? 81 and 54. What number do they have in common that could definitely make these smaller? I think 27. Okay. Now, if you're thinking 9, that's definitely an answer, but then you're going to have to reduce again. So I'm thinking of the number that they have that's the greatest. So 27. So if I divide 54 by 27, that's 2. And if I divide 81 by 27, that's 3. Okay? So now I've made these numbers smaller, and I can go ahead and just combine this away. So 2 times 2, that would be 4. The x's, I add them, that would be 5. The y's, I add them. Keep in mind this is a 1, so that's 4. Denominator, the 3 and the 3, we multiply, that's 6. The x's, that would be 3. And the y's, that would also be 3. Okay, one last step here. Subtract the exponents, and that 4 over 6 can definitely reduce one more time. So if you divide them each by 2, that would be 2 over 3. X's, let's subtract those, that'd be second, and y to the first, which is just y. Okay, so there's your final answer. 2x squared y over 3. Great. Moving on to number 16. Number 16, again, showing division. So right away, go ahead and flip the problem. Now I see subtraction, I see addition. Oh, actually I don't see addition, just subtraction. So I'm going to go ahead and factor. 9x squared, however, is going to stay the same. So I'm going to just bring that down to the next line. Now 6x minus 3, I know that 3 is a common factor, so divide that, and you're left with 2x minus 1. Now, numerator and the second fraction, they both have an x in common. So we divide an x, and we're left with 2x minus 1. Okay, second fraction denominator, I see a 3 is a common factor and x. So divide them each by 3x, 3x. And you're left with x minus 4. All right, now comes the fun part. Let's slash out whatever's the same. Okay, here, so I see 2x minus 1 is gone. All right, this x is gone. And you might be wondering, wait, why are you allowed to do that? Because it's in multiplication form. So you're allowed to cross those out because nothing right here, there's no addition or subtraction. So you can do that. Now this 9 and this 3 will turn into 3 over 1. Okay. And actually, there's one more thing, believe it or not, that you can cross out. Now this 3 and this 3 cross out. So let's see what's left. X squared is left in the numerator, and denominator is just x minus 4. Okay, so that problem was a little complicated. Sorry if you were a little confused there. All right, last problem. In the last problem, again, showing division, so we're going to have to change that to multiplication, but just to save some steps and time, I'm going to start factoring the first one. So in the first numerator, that's product is 3, sum is 4. And this is the Australian method. And again, go back to the factoring video if you don't know what I'm talking about. So there's a leading coefficient here other than 1, so we have to treat this problem a little differently. Okay, so two numbers that multiply to 3 and add to 4, that's easy, 3 and 1. So what do you do with 3 and 1? It's not the same as the other product and sum. So this is how it works. Once you find out the numbers that work, you write them 3, 1 with like a space in between. You put them over whatever your first term is, but without the second power. Now, if you can reduce a fraction, reduce it. So the first one can reduce, right? These turn into 1. And after you've fully reduced your fractions, you go bottom to top. So this x plus 1, 3x plus 1. So again, bottom to top. All right, that's the first one. Now the denominator, x to the second minus 4 is difference of squares. So that would be x plus 2, x minus 2. Okay, let's bring down that multiplication. And then let's flip this fraction. So that would be x plus 1 in the denominator, which can't be factored. So it's just going to stay like that. Now x to the second plus 8x plus 12, which now becomes our numerator. I'm going to go ahead and factor that right away. Again, this is product and sum, just regular, so nothing fancy here. What two numbers would work? 6 and 2, right? So that would be x plus 6, x plus 2. Now the fun part. Let's slash out. What is this color? Oh, this is saying, all right, let's be fancy here since this is the last problem. Let's use pink. Okay. What's the same? X plus 1 by tu, x plus 2 by tu. And nothing else is the same. So now that whatever's left over, we just put together. We're not going to multiply them. That would be more work than we need to do. And then that denominator. And that's it.